Hi everybody, welcome back to the section 2.5 video. In this video, we're going to look at a second example of a Bernoulli equation. So here we have dy over dx minus y equals e to the x over y squared. So this right here, that y squared times e to the x on the right hand side is a good indicator for a Bernoulli equation. Okay, some y to the power. So let's go ahead and try to solve this, all right, with our same step-by-step method. So here we'll say step zero. Always start with the step zero. Get our equation into standard Bernoulli form. Remember, Bernoulli form is dy over dx plus p of x times y equals q of x times y to some power. Okay, but looking at our differential equation, this is already in standard form. So step zero, get in standard form, but this is already in standard form. And note that here we have y squared. So this means n equals 2. So here I'll say, n equals 2. So what we want to do now is move on to step one. Okay, so step one is where we start our substitution process. So step one is, we want to identify what u might be. So u equals y to the 1 minus n. And we want to solve for y and our derivative of y dy over dx. So let's go ahead and try that out. So we know n equals 2, okay? And that means u equals y to the 1 minus n, just rewriting it again. We know n equals 2, so y 1 minus 2. This would be y to negative 1, and that would be uh, u equals 1 over y. Okay, so we have our u, but remember we want to solve for y and dy over dx. So we need to do a couple of things. We need to use some algebra and calculus to solve for y and its derivative. So algebra, we have u equals 1 over y, and I want to solve for y, so we'll just reciprocate and get 1 over u. Okay, and we're going to use calculus to get our derivative. So the derivative of y is going to be negative 1 over u squared du over dx. Okay, the derivative of 1 over u is negative 1 u squared. So, in case you're unconvinced, it could be you would bring this up to the top. Power rule, it'll be negative 1 u to the negative 2, which is just negative 1 over u squared, in case you're not convinced. Okay, but that's something we should be able to do in our head at this level. But let's go ahead and keep moving forward. So we have our y and our derivative of y in step one. So let's go ahead and move on to step two, where we start substituting into the differential equation. So step two, substitute y dy over dx into differential equation. And so if I substitute these terms into differential equation, let's just rewrite it for reference here in this step. Dy over dx minus y equals e to the x y squared. And so we're going to substitute in now our terms. So This would be negative 1 over u squared du over dx minus y, which is just 1 over u, equals e to the x times y squared, so 1 over u squared. Okay, so let's clean this up. Let's simplify some of these terms. So this would be negative 1 over u squared du over dx minus 1 over u equals e to the x times 1 over u squared. Okay, so we substituted back in our y and dy, and now we have a differential equation. So differential equation in terms of u and x, which is our goal. Okay, so that's step 2. Let's move on to step 3. And step 3 is always our linear equation time. Okay, our linear equation time. And the first thing we always want to do is get du over dx naked. Okay, because we want to get into linear equation standard form. Which is dy over dx plus p of x times y equals q of x. Okay, so similar to Bernoulli, but without the y to the power on the right-hand side. But that's our linear equation standard form. So we want to get our new differential equation into this form. And the first thing we got to do is get the derivative naked. So what do we have to work with? Negative 1 over u squared du over dx minus 1 over u equals e to the x times 1 over u squared. I want to get du over dx naked, so what I want to do is multiply both sides by negative u squared. And so that'll cancel out the negative u squared attached to my derivative. And, some things will also cancel out as well. On the right-hand side, the u squareds, the u in this denominator. And so what I'm left with is du over dx mine, no, it would be plus negative times a negative is a positive u. So this would be positive u equals negative e to the x. Okay, so this is our linear equation in standard form. So let's notice a couple things. The e to the x, that would be my q function. And then u is our variable here. And we just have that invisible 1 attached to it. There's like a 1 here. And so that would be my p function, my p of x. And just remember that, you know, we just have a u to the single power here. So this is a good indicator that we are on the right track. That u to the first power. But same thing with the linear equation. We got to solve it. We got to get a integrating factor and multiply to both sides. So what we need to do is get our integrating factor. So here I'll say like integrating factor mu of x equals e to the p of x dx. Okay, we set our p of x to just 1, so this would be a pretty nice integral to do. So this will just be e to the x. Okay, so that works out pretty well. And then we're going to multiply both sides by the integrating factor. All right, solving this linear equation like we normally would. So we're going to take this du over dx plus u equals negative e to the x, and we're just going to multiply both sides by e to the x. And so what we are left with is e to the x du over dx plus e to the x times u equals negative e to the 2x. And so this is what we're left with after multiplying by the integrating factor. So remember with linear equations, like we want to have a derivative of a product. Okay, so e to the x would be f, du would be g prime, e to the x is f prime, u is just g. So what we have now is a derivative of the product e to the x times u. And so, that's my f and that's my g. Okay, so d over dx e to the x times u equals negative e to the 2x. And we go ahead and integrate both sides now. So what I'm left with is e to the x times u equals the integral of negative e to the 2x. Well, this is like a mental, I'll say like mental u sub situation. And you could check me on this, but if you could believe me that it's negative 1/2 e to the 2x plus c. Okay, so just a simple u sub. If you're not convinced, try it off to the side, but just for the sake of the problem, we'll keep it moving. So e to the x times u equals negative 1/2 e to the 2x. So we want to solve for u to eventually get to y. So let's divide both sides by e to the x. And so what I'm left with is u equals negative 1/2 e to the x plus c over e to the x, because the 2 would cancel out with the e to the x. Some exponential properties. And what else could we do? We can maybe bring up this e to the x to clean it up. So u equals negative 1/2 e to the x plus c e to the negative x. And then step 4 would be to substitute back in y. So note u equals 1 over y. So if I substitute back in y, it would be 1 over y equals negative 1/2 e to the x plus c e to the negative x. And so I want to solve for y, and what I will eventually get through some algebra is y equals 2 over negative e to the x plus c e to the negative x. Okay, so that's just me solving for y, but that is the solution. Okay, so no domain issues with interval of solution because we have exponents in the denominator and they could never be zero. So no interval of solution issues here. But that's it for this problem. We solved the differential equation using substitution. Once again, these take a while. So you just have to pace yourself and make sure that you are getting the right indicator that you just have u to the first power. You are getting some derivative of a product when you get to your linear part. But they take a while. Take your time and make sure you're getting these right indicators. But that's it for this video. Thank you for watching, and I'll see you in the next one. Okay, take care.